All right, so I got another trick for you. We're asked to solve, something with a sine squared and a cosine this time. So it's not the same trig function both times. What we want to do is we want to rewrite this so that there is just one trig function. Now, there's not really a pretty way of taking cosine and converting it into sine, but there is a nice way to take a sine squared and convert it into a cosine. All right, remember how sine squared plus cosine squared is equal to 1 from our Pythagorean identity? All right, if we move the cosine squared over here, we get sine squared is equal to 1 minus cosine squared. And this is using this replacement is going to convert everything in terms of just cosine. It makes our whole equation only cosine. So I'm going to do -4, and I'm going to replace my sine squared part with 1 minus cosine squared. Okay. And we'll have to distribute this negative inside. That's going to become -4. -4 times that is going to be +4 cosine squared. 7 cosine. And I guess I'm going to need to move this 7 over to the left-hand side. So make it a +7 equals 0. We can combine those real fast. This is going to be 4 cosine squared plus 7 cosine. Oh, I forgot my x. That's okay. And then a -4 and a +7 are going to make a 3. All right. Now, everything's in terms of cosine. It's all on one side of the equation. And, yep, I've got a quadratic in cosine. So we can solve it by factoring. This one might have some options. This could either be a 2 cosine and a 2 cosine. Which one's going to work? I guess I just need to try one. Let me try 2 cosine and 2 cosine. Now the order here isn't going to matter. This is going to be a 1 and a 3. This will not give me a 7 in the middle, so this combination doesn't work. See, this gives me a 6 cosine and a 2 cosine, which gives me an 8, not a 7. So this factored form doesn't work. It's going to have to be the 4 cosine and the 1 cosine. Okay, my 3 is going to have to go on this side, and my 1's going to have to go there. That way I get a 4 and a 3 to make a 7. Nice. Everything's plus signs, making it easy on us. All right, now we can set each of these factors equal to 0 and solve. So we're going to have 4 cosine plus 3 is equal to 0. And we're going to have cosine plus 1 equal to 0. Take care of the easy one first. There's only one place, there's only one x value where cosine is equal to -1. What is it? It is at the 180 degree mark. So some of our answers are going to be 180 plus 360n. Okay, this one over here is not going to have nice solutions. We're going to get cosine equals cosine of x equals -3/4. And so we're going to have to use our inverse cosine here to get the solutions. Oh, -3/4, isn't it? All right, there's one of them. 138.6. All right, plus or minus 360n. And then the other, let's see here. Where's 138 at? 138 is about right there. All right, so we're saying that that distance is negative 3/4. The other place where cosine is going to be negative 3/4 is in the third quadrant. So whatever this angle is. Okay. Well, I can, how do I want to do this? Well, I'll just figure out this little missing piece right here. So if I do 180 minus my last answer, all right, that tells me that that angle is 41 degrees, but I want this entire angle right here, which is just 180 plus that 41 degrees. Okay, so I'm going to do 180 plus that. 221.4. Okay. All right, and that settles it. Those are going to be all of my solutions. Bam. All right, plug them in, make sure that they work, or just graph them and make sure that these answers are the same answers on the graph. All right, we'll solve one more. This one's a little bit faster. This one we've got secant squared and a tangent squared. All right, so here's your Pythagorean identity for it, and you get to make a choice. All right, you could either replace the secant squared with a tan squared plus 1, or you could replace the tangent squared with a secant squared minus 1. Okay, I don't know about you, but I prefer to solve tangent equations as opposed to secant equations. So I'm going to replace this secant squared with 1 plus tan squared plus 3 tan squared equals 10. All right, so this time I don't have a linear tangent term. They're both quadratics. They're to the second power. So for this style, I'm just going to try to get the tangent part by itself. So I'm going to move this 1 over to this side. And I'm going to go ahead and combine those. Tangent squared plus 3 tangent squared is 4 tangent squared. 10 minus 1 is a 9. Okay. And then we're going to divide by 4. I get tangent squared is equal to 9/4. Okay, so luckily this one, when I take the square root of both sides, these are both perfect squares, so they square root very nicely. That's going to leave me with tangent of x is equal to plus minus 3/2. So we got to solve both of these. And tangent is equal to negative 3/2. All right, they're not special, so you got to use your inverse function. All right, tangent inverse of 3/2 is going to be 56.3. Okay, don't worry about the other one because it's just 180 away. Tangent inverse of negative 3/2 is negative 56.3. We want to go ahead and move this between 0 and 360 usually. So I'm going to add 180. Oh, sorry. I'm going to add 360 to it. These are my base answers. I guess I could have just added 180, couldn't I? All right. 303.7. And then don't forget about the, on both of these, I didn't leave room for it, but plus or minus 180 in 180. Okay. That's all of them. And that is solving a quadratic trig equation using a Pythagorean identity when you have to.